Good day, students. How are you doing? This is me again, Sir Novero, and welcome to our new tutorial video. So in this video, we're going to talk about the discriminant of a quadratic equation. So first is, what is a discriminant? What is a discriminant? So what is the discriminant? So the discriminant is from, if you still remember the formula in quadratic formula, right? So x equal to negative b plus or minus square root of b squared minus 4ac all over 2a. So the one inside the radical symbol is the formula for the discriminant, right? So what exactly is discriminant is? So the value of the discriminant can be used to determine the number and the type of roots of a quadratic equation. In short, it discriminates the nature of the roots, right? It tells you what is or what could be the possible values, or what are the nature of the possible roots of that particular quadratic equation. Now, these are the cases, or the four cases of the nature of the roots, right? So first, if the discriminant is greater than 0 and it's a perfect square, right? When you say perfect square, these are 1, 4, 9, 16, 25, and so on. The nature of the roots there is are real, distinct, and rational. When you say rational, it can be expressed as a ratio of two numbers, right? And then if it's positive or greater than 0 but not a perfect square, then the roots are real, distinct, and irrational. When you say irrational, these are numbers that cannot be expressed as a ratio of two numbers. All right, so it's the opposite of rational, almost opposite, right? Okay, so again, if it's positive and perfect square, roots are real, distinct, and rational. If it's positive but not a perfect square, it's real, distinct, and irrational. So the difference is rational and irrational. Now in case 3, if the discriminant is equal to 0, the roots are equal, are real, equal, and rational. So if you still remember, there are times that when a quadratic equation, there are times that the roots there are just equal, so we just write one of the roots. So basically, the discriminant of that particular equation is 0, and the nature is the roots are real, equal, and rational. So why you might be wondering, why is it using the plural form of roots, right? So because it's referring to the two results that we will come up if we solve that particular equation. Okay, but if we write the solution, it's only one, or the root, it's only one, since they are just equal, all right, the same, and it's rational. It can be expressed as the ratio of two numbers. Now, what if the discriminant is less than 0? When you say less than 0, it's negative. Okay, if it's negative, the nature is imaginary. Okay, the roots are imaginary. There exists the roots, but it's imaginary, like it's unreal. Okay, unreal. Now let's proceed to examples on how to solve for, or how to determine the nature of the roots using discriminant. So let's go to let's have these following items, right? So first, x squared minus 5x minus 14 equal to 0. So for you to solve the discriminant of the quadratic equation, you have to write it in standard form first. So since this one is already in standard form, we can now identify A, B, C. Our A is 1, B is negative 5, and C is negative 14, right? Now what number is under the radical when simplified? B squared minus 4ac. So our B is negative 5 squared minus 4 times A, 1 times negative 14, which is our C, right? So basically, negative 5 squared is 25. Negative 4 times 1 times negative 14, that's positive 56. If you add them together, you will get 81. Now, what are the solution of the equation? So if you solve that manually there, you can get -2 and 7. Why is that? Because 81 is a perfect square. All right. So if b square is if the discriminant is greater than 0, positive, and also a perfect square, so this is the nature. Now, for example, the one we've solved earlier, 81. If we're going to solve the whole thing as a as starting from the quadratic formula, you will end up this like this, right? So basically, you will just replace these values with the values from there. But I did not thoroughly solve it, all right? This is just for representation, okay? So never mind this one. This is 9 actually, 9. Okay, 9. Positive, negative 9. Okay? So hence the roots are real, distinct, and rational. Okay? Which is -2 and 7. Let's proceed to the next item. 2x squared plus x minus 5 equal to 0. So when we solve the discriminant, our a here is 2, b is 1, c is -5. So 1 squared minus 4 times 2 times -5. So -4 times 2, that's -8 times -5 plus +40. If you add them together, you get 41. Take note, is 41 a perfect square? No, but it is a positive number. So therefore, it's our solution is real, right? It's real because it's positive. Okay? Now, but if you put it in this one, right? B squared minus 4ac is equal to 41, greater than 0 but not a perfect square. If you plug in, this is 41, sorry, 41. In quadratic formula, this you will end up into this one. So again, you will just replace b and a. Okay, this is just for representation. Square root of 41 is irrational. Okay, irrational. When you say irrational, the result of taking the square root of 41 is more or less it will not give you it cannot be represented as a ratio of two numbers, so it's irrational. Okay, so when you calculate the value of that, you will end up having a lot of decimal values. All right, so hence the roots are real, distinct, and irrational. Okay, that's if it's not perfect square, positive at the same time, not perfect square. So next, let's proceed to the next case. We have x squared minus 10x plus 25 equal to 0. So if we calculate the discriminant, -10 squared, right? Because our a is 1, b is -10, and c is 25. So -10 squared is, yeah, of course, that's 100. -4 times 1 times 25, that's basically 100. If you subtract them, you'll get 0. And the solutions are 5, 5, okay? They are just equal. If you notice, this is a perfect square trinomial. You still remember PST, right? So they have the same factors. So basically, the nature is roots are real, equal, and rational. Okay? So because if you put it in this form, plus or minus 0, square root of 0, basically the square root of 0 is just 0. So you'll just end up canceling that one. And then you'll be given -b over 2a, -b over 2a. So simply, you just have to, if you know already the discriminant, which gives you 0, you just have to replace b here, right? That's how easy it is to get the roots if you know that it is a perfect square trinomial. So hence the roots are real, equal, and rational. They are just equal, -b over 2a, -b over 2a, or 5. The one we got from this is 5. Okay? Now let's have the last nature, which is 4x squared minus 9x plus 7 equal to 0. Okay? Now, what is the discriminant? So our a is 4, b is -9, c is +7. So -9 squared minus 4 times 4 times 7. So this part here is -112, and -9 squared is 81. If you subtract this, you'll get a negative result, which is -31. if your discriminant is negative, what are the solutions of the equation? Basically, you will end up having a negative 31 here, or you will have an I. So I will explain that later. How did I will explain that. How did we get an I? Basically, the root should be 9 plus or minus square root of 31, right? Negative 31 actually. Okay, over 8. Now take note that there is a factor of square root of 31, square root of negative 31, which makes it negative, right? The other one is 31 and the other one is negative 1 actually. Okay, now if we separate that, we have square root of 31 times the square root of negative 1. Okay, now square root of negative 1 can be written as a representation of I. Okay, so we have that in as complex number. We can notate or we can write square root of negative 1 as I, slant I. Okay, so basically if you simplify this, you will have I square root of 31, which makes the equation a complex no, not complex equation, but complex expression, right? Because we have an I here. Okay. Okay, basically if you encounter like something like this, negative 31, okay, you will end up in this form. Then since if you still remember, I keep on asking this question before, is there any number when you square it by itself you will get a negative number also, right? So that it does not exist. So if it doesn't exist, therefore it's unreal, imaginary. Okay, although you can write it in this form, but if you compute that, if you graph that, basically it will not it will never really touch, okay, among the in the graphs there. Hence the roots are imaginary. Okay, the nature of the roots are imaginary. Okay, so because you will end up in this form, negative b plus or minus square root of negative 31 all over 2a. Okay, so if you try to compute the square root of negative 1, it will end up giving you a math error or math error. Okay, I guess that would be all. Thank you and